Alright, welcome. So in this video I want to show you how I've got scrolling working inside my Super Mario Brothers demo here. That is, how do I get the camera, as it were, to follow Mario as Mario moves throughout the game world. There are a couple different ways that you might want to handle scrolling in your game. However, some of those ways are going to be a little bit more complicated than others, and so I recommend following this strategy here, which is that I've created an additional object or entity for my game that I'm calling the Scene Manager. And actually the Scene Manager is going to perform a couple different roles for me. It does things like loading the entities into the level that I want. It also is going to draw some of the heads-up display information that might be posted on the screen while you're playing. For instance, your score, the number of coins, etc. These are things that I'm going to have the Scene Manager draw, but for the moment, I'm only going to focus on the one role of the Scene Manager, which is focusing the camera on Mario. Now, in Mario's normal scrolling environment, Mario has a sort of unique scrolling rule, which is the camera will scroll to the right as Mario moves to the right in the level, but it will not scroll back to the left. So I've actually implemented that version of scrolling in my Mario demo already, and let's take a look at how that works. We can see here that Mario is indeed in the middle of the scene, and we can kind of verify that by doing a quick count here. This is 16 blocks wide, but we can see 1, 2, 3, 4, 5, 6, 7.5 blocks before we reach the beginning of Mario, and indeed there's a 7.5 blocks after halfway point of Mario. And as I move Mario to the right, the screen will move with me. But as I move to the left, the screen does not move with me. And that's sort of a peculiar case of Super Mario Brothers. And in fact, I shouldn't be able to move off the screen here, but I haven't implemented that last little bit here. So I'll just show you how I've got my screen following Mario to the middle point, with Mario through the middle point, but not following Mario as we go to the left. So as I've mentioned, I've created this Scene Manager, which I'm also going to call the camera entity. And you can see here that I'm doing something special with this entity that I haven't done with a lot of the other entities, but I am going to do with the camera entity. And I commonly will also do this with my main character, meaning Mario as well, which is in my game engine, instead of just loading this entity into the game engine as an anonymous entity, I'm also going to give it a direct reference in the game engine by setting this.game.camera equal to this instance of the Scene Manager. So I should only have one Scene Manager, only have one camera in my entity list, and I'm going to give it this special name. I'm going to call it camera. So I do this. Sometimes this is in the constructor. I'm going to set a reference directly in the game engine. That's because I'm going to want every other entity in the game to be able to have easy access, easy and direct access to this object so that we can check where the camera is at any one time. Why? Because my other objects are going to need to know where to draw themselves relative to this camera object. Now this camera object is only going to have an X because Mario, at least the Mario that I've implemented so far, only scrolls to the right. He doesn't scroll up. In a more general game, you might have scrolling to the right and vertical scrolling, in which case your camera object should probably have a Y coordinate as well. As I mentioned, since there's only scrolling to the right here, my Y coordinate, I don't need it, so I'm just leaving it out. I've also let my Scene Manager keep track of a few global properties that might better belong to Mario, and in the future I might actually refactor these out to Mario. The reason I've left them here right now is because the Scene Manager is the one that's going to draw the score, draw the number of coins, and know the number of lives. So I'm actually keeping this data in the Scene Manager, but like I mentioned, might refactor that out into Mario later, because it actually these properties belong to Mario, and they should persist as Mario moves from level to level. The key bit with the scrolling that I want to look at is how do we update the X coordinate of our camera based off of Mario? Well, here I'm going to start by making a calculation of the midpoint, which is just asking the canvas what its width is and then we're going to divide that by 2. Now this calculation here, the first bit here is going to find me the midpoint, but this part, the minus parameters block width over 2, is going to give that little half of a block width worth of wiggle room. Since our Mario is a full block width wide, we're going to want the true midpoint of our camera to be in the midpoint of Mario as well. So this is minusing off the half of the width of Mario, so that half of the width of Mario will be on the left hand side and half will be on the right. Leaving this out will just mean Mario is shifted ever so slightly, half of a block to the right, which we probably don't want. The critical code here is right here, which is if the x coordinate for our camera ends up being too far to the left, that's what the less than sign here is, of where Mario's x coordinate is, but then minusing off this midpoint here, giving us that amount of space on the left for us to have visible to the left of Mario, that's what the midpoint is going to be calculating for us here. So if we've moved too far to the left, or another way of saying that is if Mario has moved too far to the right, then we should update the camera to follow Mario. And so that's this line here where I've got this dot x, the x coordinate of the camera is just updated to be the x coordinate of Mario, again minus this midpoint, so that we've got this padding. Now I'm going to do something here. I'm just going to take this line and I'm going to take out the conditional. By taking out the conditional here, I'm going to be doing this update every time, not only if Mario has moved too far to the right, but every single time I will update the camera. What this will do is enforce centering on Mario no matter what. And this is a more standard scrolling activity that you might have in your game. So let's take a look at what happens when we do that. I'm going to do a quick reload. And we see that it's actually enforced centering on Mario right away. And we can see to the left there, there's no level over there. I haven't created any level over there. I can go fall off that if I want. But now when I move, scrolling with Mario is permanent. Mario will always stay in the middle of my screen with this kind of scrolling. Okay, this is again more standard scrolling. Now if you wanted to set this up with also scrolling on the y coordinate, we would be doing exactly the same thing, with the exact same calculations occurring here for dot y instead of just dot x. Now I've liked my original Super Mario Brothers scrolling, so I'm going to reset this here. And now I'm just going to show you how this camera object is going to be used by other entities in the game. And to do that, I'm going to start by looking at Mario and look here at Mario's draw method. Mario's draw method, again, remember we made Mario's draw method fairly simplistic, and the reason why we made Mario's draw method very simplistic is because we bundled all of his animations into this one animation list, other than the dead animation, which I have up here, which means that no matter what Mario is doing, we can just index into this list and pick out the appropriate animation. So that was easy, but now we want to make sure that Mario is being drawn in the appropriate place on the screen. Now, sometimes if you actually want Mario to just be fixed in the middle of the screen, sometimes students will think, well, maybe the best way to do this is not to have a camera object at all, but just to draw Mario always at 100, 100, or whatever position Mario is supposed to be at, and then let all the other entities worry about where they need to draw. Mario doesn't have to think about it at all. That, I don't think, is the best way to do it, just because you're going to be offloading a lot of extra work into your other entities. Sure, Mario is going to be simple, but all your other entities are going to be very complex. And so by creating a camera object, you're going to have to add maybe a small degree of complexity to all of your entities, including Mario, but it's a small amount of complexity that's much easier to manage than if you were to do it the other direction. So here's this extra little bit of complexity that you would need. Normally when we are drawing our entities, as you might expect, we would want to draw them at this dot x and this dot y. But this dot x and this dot y are going to be the game world coordinates of our entities. I'm going to state that one more time. That this dot x and this dot y in our entities are going to be the game world coordinates of those entities, and that is in contrast to the canvas coordinates of those entities. What we can see right here inside of our canvas is we are currently drawing a bunch of entities on the canvas, and Mario, for instance, is in the middle of the canvas right now. But Mario's game world coordinates are distinct from his canvas coordinates because as I move Mario to the right, his canvas coordinates remain exactly the same. He's not moving on the canvas, but instead the game world appears to be moving behind him as he moves, but really in the actual code, his x and y are indeed moving to the right, increasing his x, while all of the x's of all of the other elements are not changing at all. What we are changing instead is where we are drawing those other elements relative to what? To Mario, and specifically to the camera. That's what we're deciding. So let's just focus on Mario here for a second. As I press right on Mario, Mario's game world coordinates increase, but we don't want him to move in the canvas. So how do we handle this? We can see right here that, again, as I move right, his this.x might increase, but at the same time, the logic we put into the camera object was as Mario's x increases, so does the camera's x. So this difference we calculate here should always be exactly the same, which is exactly that midpoint value that we calculated in the camera. Okay, this way, when we do this.x for Mario and we subtract off the camera's x, we always get the exact same value, that middle location. Now, that will be true as long as we move to the right, but as soon as Mario moves to the left, his this.x decreases, but remember the logic we had for the camera did not decrease the this.x, and that's what allows Mario to move to the left when we move to the left. Move to the left not only in the game world, but also on the canvas. Okay. Now, again, the important thing to this design pattern is if we're using the camera as we are to keep track of the XY coordinate of this sort of window we're using to look into the game world, then that means every other entity has to do this subtraction in their draw method to keep track of where they exactly are. And you'll notice I'm doing this in all three cases where I do a draw here. This is the draw animation for the death animation. I do the minus camera. In the draw animation, or the draw for my other animations, I do the minus of the camera. And then also in my debugging code where I draw some of my bounding box, I will also do this to make sure everything is drawn relative to the camera. Just a quick check, when I go over to look at all my bricks and blocks, they also have this logic where we subtract off x from the camera from the x. Same thing for my tubes. Same thing for my Goombas and my Koopas. And then same thing for every one of my background images as well. All of them have this same logic with the minus the camera x. Now, it might seem like there's a lot of little bit of extra effort that we have to do to put this minus.game.camera.x in there. And it's true that for every entity we create, we're going to have to remember that we need to draw them relative to the camera. But this relatively small addition to each of our entities logic is actually a very simple and easy way to take care of the scrolling. And once you have it in there working properly, you just need to remember to add this to any new entities you create, and scrolling will be handled no problem. So there's one last thing that I want to take a look at here related to the Scene Manager. I'll talk a little bit more about loading entities later, but for this one, I want to take a look at my debugging output above there for my controls. In particular, you'll notice the down button here. I want to show you here that at the moment my Scene Manager is drawn last by out of all my entities, which means by being drawn last, as you'll see here in a second, it will overlap, that is, it will be drawn on top of other entities. You can see here drawn on top of the cloud entity, which is probably what we would expect or what we would want for all of this text. It should be the last thing drawn. That means it should be on top. It shouldn't be overlapping with anything. Now watch for a second here. I'm just going to go die because when there's a little bug or feature, depending on what you want to call it here, but when I die, I'm going to reload all the entities, and this is sort of an aspect here, so I'll die. But when I reload all the entities, I get a little bit of, like I said, a bug or a feature because it doesn't really matter to me. But as we get over here to my cloud, now my cloud is on top of my scene manager. And maybe that's not how I want it. I want it to always be on the top so that it should be drawn last. How can I maintain that? Or how can I enforce that? Or why is this even happening in the first place? So to track this down, we need to be comfortable with a little bit of the asynchronous nature of what we've been doing in JavaScript. So let's track through a little bit the path that this scene manager goes on through our game. So the first thing that happens is, this is something we sort of put out of our mind now, but remember, we download all our assets and we don't do anything until we're done downloading the assets. And that's when we enter in here, and that's when I actually create my scene manager. It's actually the only entity that I add into my game engine originally in my main here is the scene manager. Why? Because I've passed off the responsibility of loading all the other entities into the scene manager. It's the scene manager's job to do that. So let's go see how I've done that. I go to the scene manager. When I declared it there, I called this constructor, and this constructor actually will call my helper function here, load level 1. So let's take a closer look now at load level 1. You can see load level 1 has a lot of stuff going on inside of it, which is one reason why I usually keep it collapsed. The first thing that goes on, this is just resetting the camera. This is setting the camera back to the beginning of the level. This is in case, like you noticed when I died, I'm going to want the camera to reset. Otherwise, when I reload the level again, my camera is set to wherever I died, not where Mario now is. Of course, if I'm following my Mario logic, it might reset the camera automatically back to Mario, but I want to make sure initially I set it back. Then all I've done is I'm loaded, and you can go through here. This is started out by loading in the background entities, the hills, the bushes, and the clouds. Okay, now why did I load these ones first? Well, remember, in the way that our game engine has been designed, it's going to process through all of the entities one at a time and give them an opportunity first to update and then to draw. For these entities, they have no update because these are the background entities. They don't do anything, but their draw is just to draw them in their appropriate location relative to the camera. That's what we were just looking at. But then we want to make sure also that when I walk in front of a hill or a bush or a cloud, that Mario is drawn in front of the hill or the cloud or the bush, not behind it. And to do that, we have to draw Mario after we draw the hills. And so my strategy here is to put all the background entities into my entity list first, because they will get the opportunity to be drawn first, and then things that come later, like, well, bricks and ground probably won't overlap with them, but things like Mario himself or other things like the mushrooms that I've created or the Goombas that might be walking around, we want those entities to appear later, and so I've added them later on in my load, load level 1 method. The last thing you'll notice I load is Mario. Mario is loaded last, so Mario is drawn last. So at least the way I've set this up here, my intention is that background entities like hills and clouds will be drawn before foreground entities like Goombas and Mario. And at least for this purpose, at least for now, just putting them in the order that I want them to be drawn is enough. However, for you and for your game, you might have higher demands than this. You might actually need to separate your entities out and know a little bit different about them. And I've begun doing that above here when I do this.game.camera equals this. This is identifying the camera as a special entity, different from the other entities. I've also done that for Mario, because maybe this Mario entity is also a special entity that all the other entities might need to have privileged access to, and so I've done that for Mario as well. Now, in so doing, this has allowed other entities to reach into the game engine and grab Mario or grab the camera as needed, and we saw how we need to grab the camera in our draw method. But I haven't actually made deliberate changes to the game engine itself yet to handle these new entities. I still, inside the game engine, just have this.entities, and I have no reference inside the game engine here to the camera or Mario. Those were created outside. Now, I think I'm going to make my first major changes to the game engine here because I do want to privilege that camera entity. I liked how the camera entity was indeed drawn last after all the other entities, and I want to maybe enforce that. So the way I'm going to do that is I'm going to go into my draw here, and I'm going to say this.camera.draw, and I'm going to just draw my camera after I've drawn all the other entities. Now at the moment, I'm going to be careful. This means the camera draws once in here and then it draws it again here. But this is just giving me the extra sort of added bonus of saying, okay, camera, make sure you draw after everything. You maybe have drawn before, but draw after. That way, if that cloud is overlapping, I'm now overlapping the cloud. Now, I might want to go back in a second and remove the old draw, but I'm going to go do the same thing here. I'm going to say this.camera. Instead of draw. And again, I'm going to do this for the same reason. I want my update to happen last. And that's because my camera update should happen after my Mario update. That makes a lot of sense, because if Mario moves, then my camera is supposed to move relative to Mario, so my camera should happen absolutely last. Okay. Now, if I wanted to do this with Mario as well, I could put Mario right before here, this.mario.draw and this.mario.update as well, to maybe enforce that the order that I'm going to do my entities is all the other entities first. That one I don't really care about. Then Mario, then the camera. I don't really see an important reason why I need to add Mario here, partially because in my list of entities, I've already enforced that Mario will be the last entity, at least so far in the way that I've designed it. And before Mario will be all the Goombas and Koopas, so I don't really need to break them out any further than I have here. The only other difference here is I really don't want my camera entity to draw itself twice if it doesn't have to. That seems to be wasted effort. But let's just make sure that this is working first. So I'm going to save this, and I'm going to try it over here. Now remember, it worked fine the first time through, and it looks like my D is indeed over the cloud. Okay, so let's go try and die. Oh, and my D is indeed still above the cloud. So at least we've now enforced that the camera gets to draw itself again after everything else is drawn. But now my camera's drawing itself twice, and maybe I don't want to do that. It's also updating itself twice. Now normally updating the camera twice, drawing the camera twice really isn't that big of a problem. Okay, we don't notice any problem here. It's not causing any side effects. But if your camera ends up doing other things, it might, having it do its update twice might cause it to do silly, weird things. I'm just going to guess at a couple. Maybe it will update your score twice instead. Every time you get a coin, it gives you 2 instead. These kinds of things, you know, this kind of side effect might creep in if you end up updating twice. I don't think it would in my game, but I do want to prevent myself from updating twice. And I think the way that I'm going to prevent myself from updating twice here is actually by just stopping myself from adding the Scene Manager in as an entity at all. So the reason it's getting called twice now is, again, let's just go back to the game engine here, is because I added these extra lines in that cause it to be called again, enforcing it to be called afterwards. Well, I'm going to stop it from being called in this line up above here by just not adding it to the entity list at all. Now this might look a little bit weird. I'm just newing SceneManager here, and normally we do something, you know, like this where we set it to some variable, but here I'm not setting it to any variable at all. If I did this normally with a normal object, that means that reference would probably get lost, right? Lost altogether. But luckily, because here I store that reference inside the game engine when SceneManager is created, I'm not actually going to lose that reference at all. It is going to exist there. And let's just make sure that indeed when I did a reload here, that my SceneManager still is getting its updates and its draws as we want it to. It was still overlapping with that cloud. And after we die here, we can just double check. Still overlapping with the cloud. So we can see that this change here has now enforced that my camera is drawn absolutely last, and it draws that HUD data, that heads-up display data, on top of all the other data. So maybe the last thing I'll do is I'll just show you how I've drawn that extra text on the screen. Drawing text on the screen isn't that tricky. We just use this fill text method from the canvas, and I only have to do a little bit of extra stuff to set up my font. I want to have my font properly here, and I've got my font just set up its size to be dependent on how big of a output that I've created here. So it's based on my block width parameter. And I'm using this special font family called Press Start to Play, which I'm just fetching from Google, the Google font families, and I'm just using this extra little style reference that I've put here, which will fetch the Press Start to Play font, and then set it to 24 pixels for at least for the body, which is where I've got some of the text just in the body outside the canvas. But then inside the canvas, this is just setting the font of the canvas and the font color to be the appropriate color. And then I'm just doing pretty straightforward or standard text drawing. You give it a string and you tell it where you want to draw it. Okay. I've done a couple things to pad some zeros on and so on, so you can steal some of this code if you like. But otherwise, this is just code for drawing the text at the top of the screen. I've got a little animation because there's a little blinking coin up there as well. But then all the rest of this is just my debug code, which is, for instance, drawing those little symbols that tell me which button I'm pressing down, as well as giving me a little bit of data related to Mario. I've got his velocity stated when I was debugging his motion problems. I needed that as well. If you want to know a little bit more about this, I think I did some in the description on adding keyboard input to your game, so you can jump back there and see how I detected that keyboard input and created this little debug code here. But that's all the rest that there is for the SceneManager. So thanks a lot for watching, and we'll see you in that next video.